topic for today that I'm going to talk is observational method and traditional survey methods to monitor rock slide. It's a very simple presentation that I'm going to hope that is fine. So again, my name is Sebastian Lobo Guerrero. I came to Pitt about 19 years ago. I did my master's and PhD. I spent 5 years there, and then after that, I started working at American Geotechnical and Environmental Services. So this presentation means a lot to me. As you can see, I'm wearing my Pitt swag. I love the university. My wife graduated also from Pitt. My son goes to Folk, which belongs is the school from Pitt. So it's pretty cool. Now, regarding my employer, just to mention a little bit, we do a lot of geotechnical design. That's what we specialize on. We work a lot with Mo and District 11 on these repairs in construction and design. We have 3 offices, one in Pittsburgh, one in Philadelphia, and one in Virginia. A couple of things just to make the presentation a little simpler and easier. I'm originally from Colombia. That explains the accent. So I save you a lot of time on that. Second thing, I know I speak way too fast, and we have a chat here. So I get super excited. If I'm going way too fast, just send a comment and say, that guy needs to slow down a little bit. And the last thing is that I'm extremely proud of what I do. I love every aspect of geotech engineering. I love everyone that works there. And, as a result of that, I tend to encourage a lot of engineers that work with me to take pictures on projects, take selfies, put them on social media, share them with friends, and do all kind of stuff like that, which is cool. But the only downside is you end up appearing on every single picture. So when I put together these presentations, you are going to see me literally on every picture. So try to zoom me out a little bit and, don't hold it against me. All right. So going really into the topic that we're going to talk today, observational method and traditional monitoring techniques. So let me just spend a little time on really what is the observational method, because it has a simple name. And I would say some people tend to, misunderstand it. When I say observational method, I have a very good friend that always, tease me saying observational method is just going and watch and take a selfie. And it's not. That's not the observational method at all. The observational method it's something that you do in real life every single day, but you don't realize you do it. And then the observational method applied to geotechnical engineering was really first, discussed by Peck, one of the fathers of geotechnical engineering. So what is the observational method? So the observational method is just to do observations, take any kind of readings, but basically try to understand what your problem is. Once you understand what your problem is, try to implement a realistic design. And this is the key. Look the word that I'm using, realistic. It's not like a typical design. On engineering every day, what we do is we do designs that are safe, and we put a lot of factor of safety, because obviously we want to have things that have very low chance of failure. Realistic design means go back to what you really think is predicting. Okay, if you want to put a little factor of safety, but don't go crazy on that. Then monitor how the system reacts to what you did and see if you need to do more or less. So that's the reanalyze and adjust and repeat. It's a constant cycle. It's going to save you a lot of money, but it's going to have some risk. I don't know if you guys follow YouTubers. My son recently is into a guy that we discovered about a month ago, which his name is Mark Rober. He has something like 50 million followers. He do engineering videos and science videos, and he talk a lot about a closed feedback loop. And this is exactly that. It's basically how can you observe, realize and implement. Just to give you a few examples in real life. Let's say if you are having lunch and you are using your fork and your knife to cut a steak or something like that, you don't calculate how much force are you going to put on that fork. You don't calculate how much force you're putting on that knife. You just do it, correct? I mean, you just do it, and your brain gets the information and reanalyze it all the time and see if you have to put more pressure or less. So that's pretty much what we do here. Just think all the activities that you do when you walk, when, all things, when you put a nail on the wall. So that is an observational method. I mean, it's basically a constant loop. So how do we apply it in landslides and geotechnical engineering? So the most economical, feasible way is that you start by surveying points. So let's say that we identify there is a problem, an owner contact us, we go to site, we try to put monitor points, and then we try to follow the X, Y, and Z coordinates so we can see what is happening, with the thing. I mean, where is it moving? What area is moving? And all that. Obviously, there are two things that you are concerned. The rate of movement, but also the direction of movement, and also what areas are moving and what areas are not doing. And don't worry, I promise, I'm going to give you an example in a few minutes so this becomes a little easier. You can also just do direct tape measurements, correct? I mean, you can just do observations, put physical points. You can also do drones. Anything that is providing you information will be extremely useful. I call it that it's really successful when you are limited in time and you don't have the luxury to put inclinometers, extensometers. Like you're going to see along this seminar, my coworker Suresh Gupta, he has a really good case that we work with inclinometers for about 10 years, monitor a landslide for 10 years. I mean, that is very sophisticated, technology. Melia also is presenting about that. What I'm presenting today is back to basic. I mean, if anything that I pretend that you learned on this is the observational method, and also that you see how I do things and how do I enjoy to simplify problems. So this is a rock slide that we worked on about 4 years ago in Altoona. It's in Logan Town Center. It's behind the shopping area. They have a rock ledge there, and these cracks start opening. That's when they call us and we got involved. So on our first visit, we installed nails and we basically installed control points. They are not as big as the red points that you see there. I mean, these literally were nails. I'm just doing that drawing so you can follow them. But we basically just put a line there. We measure direction, and then we start following. You start continue measuring. A few days, weeks later, you can see how that joint opened to a point that we can put one of our engineers inside. And I promise we follow every OSHA, safety standard. But the point is, you start seeing where this is moving, how fast is it moving. So that's the first step. I'm a big fan of using all the resources that are available. The media tends to be a big resource. And I have to confess that I do like to work on projects that are high profile and the media get involved. Not only because of, it's cool to work on important things, but also because the media produce an insane amount of data that if you use it correctly, you can use it on your benefit. So in this particular case, the news started getting involved. The movement continues. So we were able to use all kind of, updates that they were doing and all kind of things to really understand. As I said, in this case, you can see how that joint was opening. So it was not possible to put an inclinometer. An inclinometer typically, it's just a vertical rod and you measure how much it moves in any direction. In this case, if you put an inclinometer, it will be sheared off in about 2 days. So it was not really economical to do that or practical. I put that line because I remember one day I connected to the internet and I saw this thing saying 2 others after warrant served this morning. And I just remember thinking, man, I just started working on this project and now I'm going to have a warrant against me, but it was not to us. So I thought it's a little funny to share. Okay, other ways to estimate this movement or to see and understand the problem is just direct measurements. In this case, this is kind of like a textbook example. You typically don't see this kind of geometry. We were able to actually see on that scarp of the slide and literally just with tape measure and see how fast it is moving. Where is it moving? I would say one of the most recent developments, and obviously most people in this presentation are really young, in the audience. So for you guys, drones and things like that are very standard, but, for us are not. It's kind of recent. So one of the main things that you can use is a drone. So let me just share a video here. See. Okay, so this is a video at the site that was done in 2016 while we're still trying to understand what happened. This is not a video that I did. This is public information online because we had a drone and when we put it up in the air to try to take this, a wind came and literally just crashed it. It was brand new. It actually belongs to the EATS group in Altoona. It was our partner on this project. So we were saying, man, we need to buy another one and start doing this again. But then we find out that these guys were doing like flights every week and they were putting the updates. I think the website, technically, it's a school for drone pilots, but they were doing this on a regular basis. So we started using their images, try to understand where is this moving, how is it going, and things like that. This project had all kind of issues with those electric lines that you see there. It was a gas line and all kind of things. So, it's kind of useful to use the resources. While I have you on the internet, let me just show you. This is a cool picture that I got in 2003 with Raul Velasquez. He will be presenting next week. He also works on all this. He did not graduate from Pitt, but he spent a summer at Pitt. So that was in SB90. So if any of you at some point go to SB90, that's the way that it used to look, and that's the way that I guess I used to look. And then the last thing that I have is on the internet is we did a lot of, studies, and we published a lot of information on this particular case, but the Deep Foundation Institute, which I recommend, is a professional society. We deal with all kind of deep foundations. One of the applications is Landscape Stabilization. There is a magazine. I tend to publish all my work there. And I'm also the chair for this year conference. So if at some point you want to spend some time online, just look Deep Foundations, Deep Foundation Institute, and you're going to find a lot of cool resources. But what I want to show you is this page 83. This is the article that we did. It has the whole theory documented. It has the analysis, all the results, and all that. So I'll stop there for the DFI. But just know that there is plenty more about this project. If you want to know more, I'm always happy and excited to talk about it. You can find me on my email. I believe is on the information that you will be provided. But you can also look me up on LinkedIn, and I always communicate with people there. So all right, going back to where I was. So, once we have all these, we use all the information, we're really able to understand what's going on. So, we went there and specifically put more monuments and more control points. And we defined the areas that were moving and the areas that were not moving. So one of the big steps forward in this project was we were able to determine a non-movement zone, which is the one on the left. So we knew that part was stable. And then we have a variety of blocks on the right side. And those were the ones that we were monitoring. And it also kind of gave us a clue that it was not going to be easy to stabilize those blocks because they were moving too fast. We were measuring about 2 inches a day on the active blocks. So initially, going on the observational method, our first attempt was to put a buttress at the bottom and see if we could stabilize the whole thing. But then we couldn't. So that's the reason. All right, so I have 2 minutes. I'm getting close to the end. So we couldn't. So that's the reason that we end up just, changing gears. This is kind of like a schematic of the design. So we end up just forgetting about the buttress that we were putting, and we designed these shear pins, total of 110 pins, that we put on the part that was stable. So again, my intent on this presentation is not to talk about these pins, but it's just to, just to say we implemented this, we kind of instrumented, we saw how it reacted. If you want to know more about the pins, I can talk for hours, but you can also look at that paper. So after the remediation, we monitor it. We continue, we analyze the reaction. As we install the micropiles, we make sure that everything was, or the shear pins, we make sure everything was stable. And then at the end, once we stabilize the upper part, we just took care of the block that was sliding, and that's it. It was a very successful project. We continue to monitoring once a year. Everything seems to work, and by using the observational method, we save a ton of money instead of just going with a very conservative design. So to that, I have to slam you with a few pictures that show my love for Pitt, and with my son and with other people there. And I appreciate your time. I appreciate your attention, and I'll be happy to talk about any questions, or if you want to just contact me on a personal level, I can also do that.
Thanks, Sebastian. I think we have time for 2 quick questions. Dr. I asked if the buildings adjacent to the landslide were ever in danger.
Correct. They were, because when it was moving so fast, when it was moving so fast, the owner of the shopping area was concerned about that. So we actually have to recommend that they completely shut the electricity down for those cables. And we also say that, they shouldn't be operating there until we start constructing some kind of buttress. With a few days, we constructed a little buttress below, and we put like some kind of a steel fence. And then we say they can open again, but they did not have electricity for about 2 weeks. Or they have, but it was on a generator, not on the other one.
Cool. And then one other question. How did you establish which constitutive rock model to use to model the rock movement?
All right, so that's the other thing, man. I'm a simple guy. I did my PhD at Pitt, and I love it, but I live in a simple world with simple solutions. So every time anyone asks me constitutive models, man, the only thing that I know is elasticity, Moore Coulomb, and what you learn on a undergrad. I mean, I think I have made a career of simple solutions to complicated problems. And I think that's the value that a Pitt education really brings here, which is there is nothing more important than fundamentals. And I can guarantee you that you can have a successful career just with fundamentals. If you understand the basics, you can solve everything. So more
Awesome.
Coulomb is pretty good. Never deviate from that.
Stick with the basics. Awesome. Thanks, Sebastian. Great talk.